So this is chapter 16, number 14. So I'm going to assume that if you are gotten this far, you know what a discrete random variable is. You bothered to read the chapter and everything. All that a discrete random variable means is that it is a variable that can hold a distinct and set number of values that are not continuous. So like in this game here that's referred to in number 14, that's introduced in problem 6, you can win $100 if you break the balloon on the first dart, and then you can get $100 if you break it with the second dart, again, or so on. Okay, now it costs $5 to play, and you're willing to spend $20. So here's the situation. The small italic x in this table, I'm doing number 6 here. We're going to have two small variables. We're going to have the number of throws that you're going to make, and we're going to figure out in problem 6 the expected number of throws, or the mean number of throws. And then we're going to figure out how much money on average you expect to win. And so the nomenclature for this, the random variable itself is referred to by a capital italic X, and the mean has this capital italic E that stands for the expected value of X. Now, the expected value of a discrete random variable, capital italic X, is simply the sum of all the individual values that the discrete random variable can hold times the probability of each of those values. So for instance, since you're only going to spend $20, at most you can throw 4 darts, since each dart is $5 each. Okay, so you're going to spend, now each time you win it's $100, but I think it says you want to play until you win. Okay, once you win you're going to stop playing. So if you break the balloon on the first dart, since you estimate that on any particular throw you have a probability of 1 out of 10% of hitting the balloon, then the probability that you break the balloon on your first throw is 0.1. So the probability that you're going to throw the dart once is 0.1. And the amount of money you're going to make is $95. That's what you're going to net, because you spent $5 to throw the dart. You get $100 back, so you net $95. So if you hit the balloon on the first dart, you win $95, and you've thrown the dart once. So the expected value for X in terms of the amount of money is $95, and the expected value for X in terms of the value for X in terms of number of darts you've thrown is 1. Okay, now you've still got $15 left. Let's suppose you didn't hit the balloon on the first dart. Okay, the probability that you missed, here, let's do it like this. Let's reverse these. So the first dart was a miss, okay, because you're on your second dart now. So the probability that you missed is 0.9. And then on the second dart you hit it. Okay, now you've spent $10, so you're going to win 90, and you threw 2 darts. Okay? So 0.9 times 0.1. Missed the first dart, hit it on the second dart. Okay? You threw 2, you made $90. Okay, now let's look at the scenario. Next, you missed the first 2 times. That's 0.9 times 0.9, and then you hit it on the third dart. You spent $15, so you win 85, and you've thrown 3 darts. You miss, now the next situation is you miss on the first 3 throws. 0.9 times 0.9 times 0.9. You hit it on the fourth, times 0.1. You've spent $20. You've won $80. you've thrown the dart 4 times. The last situation is you lose $20. You win nothing, and you've spent 20, so you're minus 20. The probability of that happening is 0.9 times 0.9, a miss, and a miss, and a miss, and a miss. And you've thrown 4 darts. You've spent $20, and you're not going to play anymore. So that's the end of it. Okay, so here's the table which shows this probability situation. Now, the first thing they want you to know, in B, and we'll go ahead and figure this out. So we're going to do problem 6. We're going to do all the answers, because we're going to need these answers. We're going to need the answer to C, anyway. But let's do B anyway, just for the heck of it. So we want to know the expected value of the number of throws. On average, how many times are you going to throw it? Well, that's simply the sum of the probability of X times X. Okay? So the probability of 1 throw is 0.1. The probability of 2 throws, probably 1 throw is 0.1. Probability of 2 throws is 0.1 times 0.9. The probability of 3 throws is 0.9 squared times 0.1. The probability of 4 throws is 0.9 times 3 times 0.1 plus 0.9 to the 4th times 4 times 0.9 to the 3rd times 0.1 times 4 plus 0.9 to the 4th times 4. Okay, so you add them all up and you get 3.439. That's the expected number of throws. Okay, now we're going to use the same approach to calculate the expected number of winnings. So we'll take, what's the probability of winning $95? 0.1 plus the probability of winning 90, 0.1 times 0.9, plus the probability of winning 85, 0.9 squared times 0.1, plus the probability of winning 80, 0.9 cubed times 0.1, and the probability of losing 20, negative 20 times 0.9 to the 4th. Okay, we add all those up, and we get $17.195, and we'll round that to 17.2. All right, so that's the end of problem 6. Okay, now, to find the standard deviation of an expected value of a random variable, you take the sum of every particular possible value of the random variable, you subtract the mean and you square that, and you multiply it by its probability, and then take the square root of that sum. This is the formula for it. Now don't worry about, we're going to do one of these by hand. Later on, you'll see it's easy to do on a calculator. Well, let's just do it by hand. It's not that hard. So I just set it up here. So we're going to take 95. And notice how this follows the pattern for the standard deviation in general. Okay, in other words, we take y minus mu squared. Okay, we're going to, and then we're going to add them all up. Okay, now, and then divide by n minus 1. Instead of dividing by n minus 1, we simply multiply it by its probability. It has the same effect. Okay, so 95 minus 17.2 squared times 0.1 plus 90 minus 17.2 squared times 0.1 times 0.9. That's the probability of winning 90. And so on. 85 minus 17.2 squared times 0.1 times 0.9 squared plus 80 minus 17.2 squared times 0.9 plus times 0.1 times 0.9 cubed plus negative 20 minus 17.2 squared times 0.9 to the 4th. We add all of that stuff up and we take the square root. Okay? Now, just the sum of all those numbers, that's what's called the variance. Okay? So the variance of this random variable is 2650. It's approximately equal to 2650.057. Okay, and if we take the square root of that, so the standard deviation equals the standard deviation of the expected value is approximately equal to $51.48, which is pretty big. It's a big standard deviation, and discrete random variables are going to tend to have big standard deviations. So that's it for number 14. It's just a straight application of the formulas for calculating the mean and the standard deviation of a discrete random variable.